Hi guys, welcome back. This is 7.1. We're doing the actual problems from this section now. I'm looking at the third page, which is the page that follows all those definitions. It's the one that begins like this. A cell phone advertisement promises blah blah blah. A lot of the stuff, it's going to make more sense, I think, in 7.2. Right now, we're just looking at how the problem sets up, and we're not actually getting into much of the meat of the question yet. But let me just look at this first question. This is number 1. Number 1A. A cell phone advertisement promises a battery life of at least 24 hours. So that's what they're claiming. You suspect that the battery life might be overrated. So you're trying to test their claim. You're trying to test that hypothesis. Let mu be the mean battery life for the advertised cell phones. Cell phones. I can't read, sorry. Okay, letter A. What is the null hypothesis? H naught. Well, the null hypothesis, let's actually do the null hypothesis and the alternative hypothesis at the same time. So H naught and HA. This is a 0 here. Okay, what is it? Well, it always has the same form. It's always going to be mu something, mu something. The null hypothesis, remember, is the one that includes equality. So it's going to be equal, less than or equal to, or greater than or equal to. If you look at the claim, it says the cell phone advertisement promises a battery life at least 24. At least means greater than or equal to 24. So that's the part that has the equality. Greater than or equal to 24. Which makes the alternative hypothesis, its complement, less than 24. So you think it's less than 24. Okay, now the letter C. What is the hypothesis? I'm sorry. Which hypothesis is the claim? Can't read again. Which hypothesis is the claim? It's the claim of the cell phone company, this part. So I'm going to write as my answer, H naught is the claim. This is something we talked about briefly before, but the claim could actually be either one of these two. It just depends on context. So you have to pay attention to what the question actually asks. And finally, letter D, which test should you use? So to figure out which test I should use, what you want to look at is the alternative hypothesis. It's always the alternative hypothesis. And you look at the direction the inequality is pointing. So here, look, it's pointing to the left, right? That means this is a left tail test. So to answer the question, letter D, I want to use the left tail test. Okay, I'm not gonna draw the picture for this one. The picture is on the second page when we're talking about definitions. And once we get to actual questions in section 7.2, then I'll draw you the picture and we'll kind of do more interpretation. For now, that was the whole setup. Let's move on now to question number 2. As always, guys, when I'm doing these, because it's on a video, you can freely stop and start. You can pause it. You can fast forward it. You can play it at double speed if you want to. You do whatever you want to so that you can learn the stuff as best as you can. Okay, number 2. A company manufactures ball bearings for precision machines. The average diameter of a certain type of ball bearing should be 6.0 millimeters. To check that the average diameter is correct, the company formulates a statistical test. Okay, interesting question. Actually, this is very kind of important thing in manufacturing. Before Japan, they used to be known to actually not be very good at manufacturing back in the day. This is like back when US was actually ahead of them. But eventually they became so good at precision that they're now, of course, renowned for all of their kind of manufacturing, like Toyota and stuff. The reason why their cars don't break down is because they have such precision for things like ball bearings or things like screws or whatever it is. Anyways, that's a side note. Let's look at the question. So what's the null hypothesis? H naught. Remember, H naught is always the one that includes equality. So let's look at H naught and look at HA at the same time. And these null hypotheses and alternative hypotheses, they're always going to start the same. They're going to be mu something equal to, less than or equal to, greater than or equal to, or for the alternative without the equality. It says, let's see. You want to check that the average diameter is correct, meaning it can't be more, it can't be less. It must be exactly equal. The average must be exactly equal to 6.0, right? So the alternative would be that it's not equal to 6.0. Right, when you have a not equal, that means it's going to be a two-tailed test, but I'm getting ahead of myself. Let's answer the questions in order. Letter C, what hypothesis is the claim? The claim is that the ball bearings are precise, that they are 6 millimeters. So this would be the claim over here, the top. Again, it doesn't have to be. It just so happens that both times so far they've been H naught, but it could be HA, the claim. Okay, so we'll say H naught is the claim. And then letter D, which test should you use? Well, if you look at my alternative hypothesis, not equal to means it's going in both directions. It's on both sides. So this is a two-tailed test. And I'm just writing this down twice for no good reason. I should write my answer down here. We're using the two-tailed test. Okay, sweet. We're almost there. I think we have just one or two more questions. Oh, two more. Yeah, the last one is a different type of question. Okay, let's move on to number 3. I'm on the next page. These guys aren't so bad, yeah? This section is actually pretty easy in terms of the questions. I'm just setting up problems. I'm doing no calculations at all. Okay, number 3. Your dad claims his average toenail length is over 5.4 centimeters. What's the null hypothesis? And what's the alternative hypothesis? Okay, like I said before, these always start the same way. Mu something, mu something. Let's look at what he claims. He claims his average toenail length is over 5.4. That's strictly over 5.4. So that's the one that does not have equality. This time I'm going to start from that alternative. Strictly bigger than 5.4, which means the original must have been less than or equal to 5.4. Because the alternative must be the complement of that, right? And the way I wrote it, this is actually the claim the first time, right? The claim is that it's more than 5.4, over 5.4. So this time, which hypothesis is the claim? The alternative hypothesis is the claim. And then which test should I use? So again, I look at my alternative hypothesis. I should use the right tail test because alternative hypothesis is pointing to the right. So this is a right tail test. Okay, shoots, that's it. That's number 3. So I'm going to erase now, and let's move on to the last one. Last question. Now be careful, like the way we use our language. H naught, although it's the original hypothesis, that does not mean it's the claim. Like we just saw in this previous question, the claim was actually the alternative hypothesis. Yeah, H naught is just the hypothesis that has equality attached to it. Okay, number 4. This is just a recap. We've seen these two things, type 1 and 2 error on the first page. Type 1 error, remember, is when you reject a null hypothesis that's true, and type 2 is when you fail to reject a null hypothesis that is false. Okay, number 4. Describe the 2 types of errors for a hypothesis test of the following claim. A furniture store claims that at least 60%, that should be of its new customers will return to buy their next piece of furniture. Okay, so first H naught and HA. Actually, it's not important that we know to answer this particular question which one is the claim, because it only asks for the type 1 error, type 2 error. So we just need to know what H naught and HA are. H naught, you see the furniture store claims at least meaning greater than or equal to 60%. So in other words, the claim is that mu is greater than or equal to 60%. Yeah. Or you can write it as 0.6 if you prefer. And then the alternative then is that mu is strictly less than 60%. Okay, so now the question asks, what are the 2 types of errors? What would it look like? Interpretation. So type 1 error, what would that look like? And basically, you're just going to write a sentence. What would that sound like? Type 1 error would be rejecting the hypothesis that is the mu is bigger than or equal to 60%. So that would be when I say, this would be like, I'm gonna write a phrase here, not a complete sentence, but rejecting the hypothesis that mu is bigger than or equal to 60% when in fact mu is bigger than or equal to 60%. That will be the type 1 error. Yeah. So you reject the hypothesis, the null hypothesis, when in fact it's true. Okay, so type 2 error is similar idea except in the other direction. This time let's do it in blue. So that would be failing to reject the hypothesis that mu is greater than or equal to 60% when in fact mu is less than 60%, strictly less than 60%. So I fail to reject mu being the fact that mu is greater than or equal to 60%, but in fact mu is less than 60%. So in fact it's false, but I fail to reject the hypothesis. That's the type 2 error. Alright guys, that's it. That's it. We're done with 7.1. First video was 13 minutes. This one's also about 12 minutes, so altogether about 25 minutes for that first section. Not so bad. Okay, we're going to move on to 7.2 next video. See you guys in however long it takes you to load that next one.